Okay. So today I will talk about a new package which is called Pandas. So far we had been discussing about basic Python and some many packages like NumPy, SciPy, Matplotlib, and so on. Probably tomorrow ADG will talk about some more new packages. But to
No,
be okay, no.
I will not.
Okay, whatever. Okay, so basically whatever the point is, we had been discussing, we had been traversing through various directions of Python, but mostly concentrating on basic applications in basic science and other social sciences. Then we talked about basically something, the major thing is the data handling and the data visualization, which will be useful for everyone, whoever will deal with Python. And then I briefly talked about image processing. And many of you, actually, I mean, all of you probably know that there had been some worldwide sensation about the black hole image. So this is, I guess, nothing but it's a kind of image processing. So that, and they used Python, and they use NumPy, SciPy, Matplotlib, and today what I will use, the Pandas, these packages, and of course the clever algorithm to take enormous number of data and to make it a shape of an image of a black hole that you saw, and that was quite a sensation all over the world. So with Python, we can do lots of things, anything probably, and we can do basically. I'm interested in data, so we can handle huge amount of data, structured data. We can plot them, we can model them, we can then feed it to the machine, and the machine can learn the algorithm. Machine can learn to behave, I mean, to act like quote unquote intelligent way, and so on. Then there are many more applications which we cannot touch in this small sessions, small days within these days, and also not all that we know about. We know little bits, some things. So that things we have touched. There are web applications, there are developmental work, there are lots of things. People who do cosmology, people who do hardcore geography, and all that, astrophysics. So Python is there for everywhere, and you will see that there will be packages. People will be using lots of packages made by the respective communities of research and development. And in my knowledge, all the packages will be mostly, the most fundamental packages will be NumPy that ADG talked about, and then for data visualization Matplotlib, and also for structured data will be Pandas. So a few packages, if you know how to handle them, then you can go to any direction of your choice and you can explore things. So that's it. So I will basically introduce Python with today I won't type anything. I will basically go through a PPT made beforehand on Pandas, and then I will go to Anaconda and to show you two applications of Pandas. That's it. And only I can tell you, this is only a small amount of, I mean, the Pandas can do a lot. Pandas is a very huge package, and so only very restricted region I will talk about. You can do a lot more things with data. Okay, let's go here, and let's go here. Yeah, and I can go to slideshow from the beginning. Well, you can see my whole screen, right? You can see my entire screen. Okay, so this is Pandas. Pandas is basically paneled data. Well, okay, so Pandas for data science mostly, but you can use Pandas for anything. So Pandas deals with the following three data structures: series, the name begins with capital S, then data frame, capital D, capital F, then panel, capital P. So these three kinds of data structure, this is the Pandas deal with, and the data comes to you from various sources. in various forms, like people write in spreadsheets like Excel sheet, people write in plain text, people write in many other forms, and sometimes people send data in zip form. All kinds of data can be deciphered by these pandas, and there are machineries, there are functions that can actually deal with this. And these three data structures, it will first convert the data into one of these forms, and then you can convert them to your known form, already known form, as in the NumPy, that is NumPy arrays. So then your life is easy, you can go on as usual. Okay. So these data structures are of course built over NumPy arrays. Okay. So we talk about series. Okay. So yeah. So to begin with, of course, for any other package, like any other package, you have to import pandas. I hope pandas is already installed on your machine, and import pandas as PD, say, this is common name we give. And then you, on your interpreter or on your Anaconda, this Jupyter notebook shell, or wherever you are typing, or Linux, you just type dir PD, just to see what is there inside. I won't show you because it will fill up all the page. And then you can also, this is also with it also, it is important to know, to have import NumPy as NP. This is everywhere. Whenever you do plotting or do any other things, NumPy is always there to help you, because you have to deal with data, you have to deal with arrays. Well, so suppose I create a NumPy array, np.arange 10, 50, 10. By now you know it will create numbers from 10 to 40, 10, 20, 30, 40 in steps of 10. And now it's simple, pd.series. So that is the function. Inside this, if you write x as argument, so it gives you this structured form. So you see 10, 20, 30, 40. So these are these are the four numbers, and this is extra 0, 1, 2, 3. We'll soon know what it is. These are as if the row numbers, 0th row, first row, second row, third row, and it also gives you the data type. It is by default integer 32. Okay, and now you can write some index, say with some strings, say for example A, B, C, D. And now you feed this into pd.series. X is your data, this NumPy array, and comma index. So you call it, say, S, say, for example, and you type S on interpreter. You see the index, by default index 0, 1, 2, 3 is replaced by your, that you want to impose A, B, C, D. So you can handle in this series form, you can handle the index as you want. So it's a kind of it's a kind of that is, the data is kind of a table, you are going towards that, but still not. So this is a series for you. Well, and like NumPy arrays, I don't have to iterate much, but for you can understand these things are based on NumPy arrays. So like NumPy arrays, you can apply the methods of this slicing, indexing, etc., all these on the series. So I'll give you some few examples. S of 0, so that is, of course, it will give you 10. You can also call by the index name S inside the square bracket, you write quote unquote A, it is 10. And then series methods. The methods means the functions applied on this. There are lots of methods you applied for all NumPy arrays and list and all that. So now s.access, it will give you the access information. So the index start from 0 and stop at 4. That means 0, 1, 2, 3, and step size is 1. So it gives you the information about access. S.values, it will give you the values in that the one we feed as NumPy array, and it may be wrong. It was integer 32. I may have typed it wrong, integer 32. You will check on your interpreter what it gives. S.size, it will give you the information about size. That means 4 data points. It will give you the shape. That means it is one-dimensional data. So it is 4 comma. It's a vector. So it's a tuple. S.ndim, like NumPy arrays, it will give the one-dimensional data. S.dtype, Of course, in this case, probably I probably imposed or something like that. You will check on your interpreter, no matter. So it will give you the data type, integer 64, say. And you can also, like NumPy array, you can also now add one extra row. So you can write, say, S. I had A, B, C, D. I had A, B, C, D. Now you can write S, E. E was not there, but now you impose as a new index equal to 50. So new row added. So now you write, and the new row, the last row is added. Okay. And you can now have a data in the form of strings, like 4 names. Now inside the pd.series, you write this list of strings, and you get these 4 names. And the index I have not imposed yet, so it is automatically again 0, 1, 2, 3, and the data type it writes object. So this is series for you. Data as scalar. So if you write index ABCD, and if you write by chance the data is single data, say 10, you have not written a series, you have not written a list or array. So it is, you have written just one number, and then you write index, and you write integers, so in the form of integers. So you have this A, B, C, D, and all the entries are 10. So it understood that it will match with this index A, B, C, D. So that is this. Okay. Now you can create series from dictionary. Like this is a dictionary you can recognize. A is a key, quote unquote, because it's alphabetic thing. So at colon 10, that means the key is A and the value is 10, key is B, value is 20, and so on. If you now feed this data in the pd.series, of course, then you don't have to give the index separately, but the keys are the indices. So the data, what was a dictionary, is now it is looking like is a more structured form. It is more, it's visible to you, like it's a kind of table. So it is now 10, 20, 30, 40, and the indices are ABCD. Now, for example, if you write, say, index A, B, C, D, E, now you try to impose a index, a list of the strings as index. Now remember, you had A, B, C, D. Now you have A, B, C, D, E. Well, and you now put inside pd.series and the data, and you have this index, right? So now what it does? Well, this is very important. You had the data A, B, C, D, 10, 20, 30, 40. And notice here 2 things. First of all, the values were integer, but here values automatically became float, and also E was not here. E was not here. So in place of E, it doesn't know what to write because the data for E was not here. So it wrote NaN. That is very fantastic thing of Pandas, because when often you get some table from somewhere, some people have typed and some people have missed some column or some entry in some column or row, and the data is with you, and the Python will interpret that missing element as a nan. Nan for is not a number. And since nan can be anything, it can be float, it can be anything, or integer. So it is so clever that it has already automatically made these the previous entries as float. Okay. Ananda or Ronavata, can you confirm me that you can hear me properly and the screen is full?
Well, I can hear you. The screen looks slightly small to me, but maybe that's
okay. Then I can make the screen full because I did something. Let me first make the full screen. Okay. Then of course I do not know how to go. Okay. Then
so it's better that you don't make it a full screen. Then it's going to be
then I'll find out the things. Okay. Yeah. Again, I go here from the slides. Okay. So
it's more an aspect ratio thing for me. The your screen's aspect ratio is different from mine.
Aspect ratio is different, could be. Okay. Yeah. So technology is always a problem for me.
Yeah, it's okay.
Okay. So but see these things I was talking about. This. So it is clear, I think. Okay. So now go back to this series ABCD, And like the NumPy arrays, it is also, you will see that it is also vectorized because it is nothing but made over NumPy arrays, the series. So if you write s into 2, of course, star 2, so all the elements are multiplied by 2. Okay, so if you write np dot square root, see, you can use the NumPy, and the NumPy will not leave you anywhere. So it will always be there. np dot square root of s. So it will be square root of all the elements. Well, so if you can likewise take the sum of the elements, all the elements, you can take minimum of these, you can take maximum, all these methods. You can do the slicing 1:3. I don't will spend more time on this because these are all familiar. What you can do on NumPy arrays, you can do on series. That's the thing. Well, you can also could write s dot sum, s dot min, etc., etc. That is nothing to do. S dot standard deviation, all these things that on NumPy array you did, you can do here also. Well, so this is the end of the series. Now I go to the part 2 on data frame. Next structure. So next hierarchical structure. Okay. Yeah.
Could you get back to your last screen a bit?
Okay. Here. Here. Is this? Ananda?
No, actually, there is a question that
okay.
Why the last command
Can
provides
you go
float?
back to the previous slide?
Previous
slide.
Yeah, so,
okay. Previous.
The question was, okay, I didn't get the question. The last command was calculation of mean.
Okay, mean. Oh, mean.
And mean, of course, yeah.
Mean. Mean was minimum value.
No. The last one. The very end, the question was something else. The question was, why is that a floating point? Now, if somebody is doing this over...
Mean means MEAN, mean. That was there? Or, oh, mean. This
mean.
Okay.
Average.
Yeah. Yes. Yeah, it is.
It's a division.
Yeah.
Well, mean here is a division. Of course, standard deviation is anyway a floating point number.
Yes. It
mean here is a division, and division returns a floating point number.
Right. Like it will happen to NumPy arrays also. You can check that. It is always that. Yes. That is the reason. Correct. Okay. So Pandas 2, and that means we'll talk about data frame. So likewise, import Pandas as PD, and you give the data 10, 20, 30, 40. Say, I mean, I can give as list, I can give as NumPy array, doesn't matter. And now, if you write this inside this, fit this inside this data frame function, pd.dataframe, inside that you did give data. So it will give the same thing, 0, 1, 2, 3, these 4 indices, as it means 4 rows. But notice here, it will give a 0. That means I have a 1 column. So it will give 1 column also. That means you can really understand that with data frame, we can identify the columns also. So that is the beginning. So it will give you the 0 here, okay, by default, because I have not fixed anything yet. And now check with this 2D list, 2-dimensional list under the list, or a 2D array, whatever, it is list. So if you have this, of course, you can understand if we write this inside. So the data is like this. So the first one goes as first row, and the second element goes as the second element means the first element means the entire list itself. So that is the first element. Like here, 10 was the first element. Okay. So this is the first element is the first row. Second element is the second row. Automatically 0 and 1. These are the indices, and these are the columns. 0, 1, 2, 3. So automatically columns are given. So now you can think of this as a table, real table. So in any table is a 2-dimensional thing, object, and in a table you have the rows and columns. Now you have the rows here, 0th row and first row, and 0, 1, 2, 3, 4 columns. That's it. So that is data frame for you. Now you impose index A and B, say, for example. And now you give inside pd.dataframe, you give D, index. Of course, all these things are just demonstrations, nothing like extraordinary things. You can go on your interpreter or shell or whatever, or command line, and you can type and see help, and inside that you write pd.dataframe and see what these functions, what are the things you can give, what are the keywords, and what are the they give examples and also lots of explanations, so you can understand how it works. Okay, you can find out yourself. So d comma index, like series. So now a, b are now index here, and 0, 1, 2, 3 are still the column numbers. Now you can also give columns. So the columns is actually a keyword. So you give inside this d's data in the form of 2D array, 2D list. Then you give index. Index already I have given here. You could write index equal to something. I wrote columns equal to this A, B, capital A, B, C, D. And now you see this is now the complete. So your data frame, now the rows are named as small a, small b, and the columns are named as capital A, capital B, capital C, capital D. So that is your that is the structured form of data you can present, and you can get, when you get the data from outside, written by someone somewhere, and you can form a data frame. And later
maybe you're moving a bit too fast because people are trying to do it along with you.
Okay. I'm slowing down.
Anyway, that's
because I have already lost some precious few moments. Okay, Orunavada will kill me afterwards.
No, this is basic. Okay, the people also had a question about why the display is like this, and is why the rows and columns look like this.
I do not need original. Don't worry for me, because I do not need more than half an hour to 45 minutes.
Okay, no problem.
Just go slow.
Okay, I go slow because I think, because I thought that. Okay, why? What is asking that why the form is like this? I mean, if somebody is asking why the form is like this, right? I don't know. They present in this form. This is all about data frame. How do they actually do that is not my concern at the moment. I know the display is like that. This data frame.
This is a convention for the display. There's no.
No. This is the data frame. This is whatever you see. You see on your shell. You just type. You see on your interpreter or everywhere. This will come in this form. The columns will come this. Of course, in some interpreters, some will be colored. Some will be something, some shadow or line draw, something like that. So more of it will know. I mean, every interpreter will show it in a different way, but the structure is this. You have the two indices, small a, small b, and you have the four columns, capital A, capital B, capital C, capital D, and the data are in this form. And the other things, I mean, the presentation means how many gaps it will give, whether it will be colored or whether it will be little bit displaced, or it will be shadow or something shade, or sometimes it will be some line over put up under A, B, C, D, etc., etc. Lots of design. Those are designs part. But the thing is that data frame is this. This is data frame. So you can understand we came from the data series, which was one-dimensional, and now it is data frame. The data is basically a two-dimensional data. So the presentation is also two-dimensional. In series, you can think of the series is basically one column, and the data frame is more than one column. So that is from something to something we go. Okay, series to data frame we came. Okay, next we will see that how you can make data frame from lots of different varieties of these data collections. That is something you can do. And then we will see that once we have already data, people type data, they didn't have in mind that whether it will be data frame or series or whatever, simply Excel sheet or whatever, or simple text file, you can convert it as a data frame. And once you have data frame, you can convert it into, there are methods to NumPy arrays. And once you have NumPy arrays, then everything life will be very, very simple. So that's my basic thing to tell today. This is again and again I will emphasize this. Okay, so this is your data frame, where so data frame is basically three important things you can give, and there are lots of other keywords. If you go and type on your interpreter, you can check lots of other keywords which will suppress the sometimes headlines, suppress these, do this thing, that thing, fill this thing. If there is there are lots of things you can ask, and you can just check yourself. If there is a nan somewhere appearing, nan data is not matching, that means there will be nan in some element in some space. So how you can omit that, how you can replace nan with some other thing, fill that with something. So there will be all kinds of methods will be there. Not all that I can talk about today, because I will go through a basic introduction of the 3 kinds of data structures, particularly 2, series and data frame, and the other panel will not be more useful. And then I'll go over to the application. That's the thing I will do today. Okay, so data frame. Well, now you see the data frame looks like this. You can type on your interpreter and see. More or less, it will be looking like this. Now, again, like series, if you write it is indexing, right? You can understand with the column now. You can now give the column A, capital A, quote unquote, because it is an alphabet. So it will write this way. See, it will write this part. So it will be small a, small b. With the indices, it is coming, and it is 10 and 50. If you write, it's like exactly like NumPy arrays. If you write this DA and then small a, that means small a means it is indicating that is the index. That means the row. Always remember, in data frame, index keyword is reserved for the rows, and the columns keyword is reserved for the columns. So that is the thing. So if you write DAA, so
another question. Is it it's unlike the NumPy, you have to specify the column first and then the row? It is the opposite convention of NumPy, right?
You can type it. I 100% not sure. Maybe both.
I don't think that should matter, because it should be able to recognize which.
That's both.
It should be able to recognize which index is which.
Yes. I'll check it.
So people necessarily
as long as you've named them. If you're not named
you
them,
have named, actually. Yeah. It is
it is necessary that the names are different. The row names and the column names should be different, right?
Of course.
It should not be any differences like.
No. Of course that. And I don't think, as ADG said, that it doesn't matter.
No, if you don't, then I guess the default will come in. I think that should be the columns first. I don't remember that. That has to be checked.
You can if you write here D say 0, that you can check. If you write instead of capital A, if you write 0, I think then it will be the first row, because 0 means it will think of the index 0, I think. So you can check that on an interpreter. When I'll go back to interpreter, I can check, and lots of our friends are actually typing. They can already type and can tell us. I think my guess is so, because earlier also for series, it was actually looking at the index, of course. So it is the index. If I write D inside the square bracket, I write 0 instead of the name. I write 0. 0 means it will understand the 0th row. So it would give the entire row, I think. You can type and check. Okay, maybe we'll come back with that. Okay, so the answer is 10. So the entire point is that it's like more or less like NumPy array, because it is based on NumPy array. Series and data frame are all based on NumPy array. NumPy array is fundamental. So you can actually through this indexing method, you can take out a particular data point from some on the table. So this will use when I will use quote unquote big data today, and I will show an application of this, how quickly we can check from a very big data set. Okay, this is very important. This indexing will be very, very useful and important for handling big data. Okay, so methods over data frame. I won't go on every method, but I will show you the list. That's it. You can understand, because you know the names, you know the access already in series. You have seen the access. It will give you the information about the access, and you know the access about by now. You know if you have a if you have a two-dimensional NumPy array, and it looks like a matrix, rows and columns. If you go down, that means you come down through rows, 0th row, first row, second row. So the arrow pointing downwards. So this is the axis 0. If you go towards column, 0th column, then 1 column, 2 column, second, third column. So you go right. So that is the axis 1. And the perpendicular to the plane, like the we were dealing with three-dimensional NumPy array in image processing. The other dimension is, of course, the axis reference will be 2. So the axis will be 0, 1, 2, 3, 4, and so on. You can generalize this for n-dimensional NumPy array. So that's why you call it ND array, n-dimensional NumPy array. Okay. So d.access, it will give you the access information, in which access what is there, like that. If you write d.size, of course, it will give you the information about size. Each of them you can try. You can just create a fake data frame, and you can check what is the size. You can check about the dimension. Of course, it is 2. You can, like the NumPy array, the whole data frame can be transposed. So d.T is the transpose. You can use the transpose function also. So you can think of the data frame is nothing but a two-dimensional NumPy array. Only thing is that the rows and columns are now indexed, now named. You have given the name so that it looks like a presentation is not like an square bracket thing. The presentation looks like a pure table. It will look more like a table later. I will show you. Okay. So if you now write d.empty, this is to check whether there is your data set is, this data frame is empty or not, whether there is a data or not. If you this is interesting. If you write d.values, it actually will show you the NumPy array. That means the data you gave, the data was NumPy array, for example, it will give you back the values. That means it will, it will cut these, it will disregard the columns and indices references. Okay, it will give you the actual NumPy arrays. If you, this is very important, d.head, I will use that. Head means it is a huge, a huge data set. Suppose you have some thousands of rows and hundreds of columns, and you have got this data set. You cannot see the data set in full, and the screen will be full of this, and you cannot go up and scroll up and down and check. So you want to see only some head part. There is a head, there is a tail. So it will give you d.head. By default, in all the places, it gives you the 5 rows. It will show you the 5 rows. You can write here some numbers, say 100. It will show you the 100 rows, etc. Similarly, it will show you the tail part. So all these methods, you just remember them, and it will be useful for handling big data. The moment you begin to handle data, real data, then it will be useful. One of our friends were asking me that whether we can show some real life application of Python today. So I said that yet it is a real life. When we do basic science, that is real life. We do geography, that is real life. There more real life will be much more data, but of course we won't do on web application. We won't do on fully on machine learning and data science kind of thing. That is, and as I said earlier, we will actually take you to the doorstep of all those things. Then it is your turn how you will explore these areas. Okay. Much to learn. We'll go on learning things. d.sum, of course, it will sum of all the elements, of course, as you know, in NumPy array. And if you have d.sum, because you understand this 0 is the axis reference. That means you go downwards. This is 0th axis. 0 axis. If you write d.mean, of course, the same. Mean of all the elements. If you write d.mean, and this is the on the one axis, that means you go right column wise, and of that will give you another one-dimensional array, right? And so if you suppose C1, so this is axis reference, this first one, and this, of course, you understand this is the indexing. That means you want to have the mean value of the row that is the one-dimensional array created of all the columns. First, suppose you have the 0th column. On the entire column, you have one value. 1th column, you have the mean of that entire column, you have the one value, and so on. So we'll get back by this, you will get back the one single row or kind of one single array, one-dimensional array. Out of that, this is the 1th. That means it is the mean of the 1th column. So that way you understand. Similarly, for standard deviation, all the minimum statistical things you can do, you can check maximum, minimum, and then as Arunahoda told, this describe is a very useful method sometimes, because if you just instead of STD, max, mean, then there will be cum sum, then sum, etc. All these values will be given by this describe. It will give you the full preliminary statistical information about the entire your data frame. Okay, so this is the what about the methods? Okay, so now data frame from dictionary. So far we have seen, we have created series from a one-dimensional array, or you can create from a list. We have created data frame from a one-dimensional list or array, and we can create data frame from a two-dimensional list or an array. Now suppose you have a dictionary. Also we created data frame from a dictionary earlier, we saw, and now we have a data in this form. So A, B, C, D, and you understand these are keys and values, and we have the index 1, 2, 3, 4, and now you write pd dot data frame data comma index, and of course I have shown this earlier. So you have now this A, B, C, D are the now the for the series probably I had shown. Now it's for data frame. Okay, so these keys are now it's important point is that the keys are now not this index. It is now, they are now the columns. So the thing is bit changed now. Okay, so earlier we probably showed you in a series from dictionary. Now we show you the data frame from dictionary, and in this the keys now do not go here on the index. Keys now go over to the columns. That is one difference to remember. And index 1, 2, 3, 4, the index you give here, index are of course imposed. If you had not given index, it would be 0, 1, 2, 3. So this is what data frame now looks like from a dictionary. Okay, so basically in the data frame you have to give data. This is essential, that is default, and then you have to give, and then you can give index, you can give impose columns, and many other keywords which I'm not addressing here. You can check yourself, and you can design your data frame in a very fancy way or the kind of way you want.
Abhijit, perhaps here the named index is a bit confusing. The point is you have given a dictionary and an array. The second array is treated as the column names, isn't it? You have given here.
No. The keywords. See, the keywords are the columns. Keywords. Sorry. Key are the columns. And but the index is the keyword. Index you cannot change. Index is the keyword.
In a dictionary is the value. Keys not the column.
You have created an array and named it as index, and you have passed it that.
Oh, no. Okay. I'll show you. You could write index equal to index or index equal to this. Index is the keyword. You will always have.
I think it is you are giving supplying an array, and that array is being treated as a named column. Columns.
No.
I mean.
No.
Why do you say column?
Column, row.
I think you're confusing. The first thing is not a column. The first one is a label for the different rows.
Rows. In Arunahoda, it is row.
The 1, 2, 3, 4 here are just labels for the rows.
Label for the rows.
It's not a separate column. The columns are 10, 10, 10, 10, 20, 20, 20, 20, and so on.
Yeah, columns are given by these the key or key of the dictionary. Okay.
The values. The column labels are the keys.
Mm-hmm. Yeah.
The row labels are the index elements.
But here you see, here you see it is a trivial thing, you see, and also a peculiar thing, also trivial and peculiar, because in the dictionary value, I have a scalar. For a column A, I have a single value 10 that I showed earlier, right? So it repeats 10, 10, 10, 10. It doesn't know what to put again. So it's the scalar, it repeats. It is so clever. For the column B, it has the single value 20. So it has 20, 20, 20, 20. So you see the same 10, 20, 30, 40, it is repeated 4 times. Later we will rectify. So the data frame will be having the data, you can give in the data, you can give in a more structured form. I'll show it just now. Okay, so that everything will be different. That I am going to show it. You can guess it now. Okay, so Arunabhoda is probably confusing with the series. In the series.
I was sorry, but I do not think here the name of that array has to be index. You can give a different name to it. Doesn't matter.
Yeah. You can.
Oh, yeah. Oh, acha. I understand. This name index I have written because I could write here index equal to index. So this name you can give anything. This index first, index equal to 1, 2, 3, 4. I have written beforehand. This index can be anything. Some x, say for example. I could write index equal to x. So that's the I think the source of confusion of you. I think maybe. Okay. We'll rediscover these things again and again. You'll see. I go to the next slide and you can understand this. Okay. But for the time being, you can understand these keys of the dictionary A, B, C, D. They go for the columns. The index is always here. Index name is very typical. Index is index. Unlike the data in the dictionary form, we gave it for I think the series. I'll show you again. Okay, there. So that there the keys of the dictionary went into the as indices. Should I go back and show you? I think how do I go back? I think I can go back and show you, right? I can go back and here. So okay, slideshow. Yeah. Series from dictionary. This is this. Here the difference here, because here is no concept of column. In the series, you have no concept of column because it's a single column only. So here in the dictionary, you give A, B, C, D. These keys, these dictionary keys, they are taking positions of the indices. Okay. Next, we impose index. I mean, this name index should. I mean, you can write anything. Then you give index. I mean, this name you could write, but this index here in this inside, this index is a keyword. You could write index equal to index or just simple index, because after data it comes the index, and then comes columns in the data frame, right? So this is for series. So there is a difference between series and dictionary. In the series from data frame, in the series from dictionary, you have the keys that they are sitting on the as index. But when you are constructing data frame from dictionary, then the keys go over to the columns. That's the thing. I can go and go and show you now again. Okay, I can yes. Now you see the difference between series and data frame. Both of them can be constructed from dictionary, and here the keys A, B, C, D, they go over to column, because here I can give index separately 1, 2, 3, 4. Because in the series you have no other option, because either you give index or entire thing can be given from a dictionary. So that is the difference. Okay, data frame from dictionary of list. Now you see, you have the real form of this data frame. Now you see, you have a dictionary, I call it data, and you have the key A, and instead of one value, I have now 4 values, 10, 15, 20, 25. So the entire value is a list. And now I have another key B, and I have the entire value of the corresponding to this key is a list, and so on. The C corresponding to another list, D corresponding to another list. And here, for the purpose of demonstrations, all the lists are of same length. Otherwise, the table will be problem, because if the one data is missing, suppose one list is of size 3, another is 4, or so on, then there will be nan. Python, the pandas will automatically recognize that there is a missing data. It will put nan. Otherwise, it is a pure dictionary. Now you see. Now I impose dictionary 1, 2, 3, 4. If you do not do impose indexes will be 0, 1, 2, 3. Now I see. I write pd.dataframe and data, comma, index. And you see, now the data are, see, these 10, 15, 20, 25. See, it comes under the column A. So that means the key is A and the value is this list 10, 15, 20, 25. The key of the dictionary is B of the data, and the value of the corresponding to this key in the dictionary is this list 30, 35, 40, 45, and so on.
Abhijit,
yes.
Abhijit, if you're trying to change dictionaries of lists into a data frame, then they have to be the same length. Otherwise, it's not going to give a nan. It's going to give an error. The nan will come when you're trying to delete a file or something. When it's dictionary of lists,
you mean here?
The trouble is,
you mean here the list? One list will be shorter than the other list. That you can say?
Yeah. Then the problem is it will not know where to put the nan.
I think nan will come here, because I can check when anyone can.
No, it won't.
Check.
I tried it.
You tried it, no?
I tried it right now.
Okay. So it is not
in both Python 2 and Python 3.
It is not a but I think philosophically it should recognize, because the column, you see, your A, B, C, D columns are fixed, and it should. What does one D column will care about A column? Because it has 3 members, for example. Suppose the D column has 3 members, 70, 75, 80, and here one thing is missing, but you have 4 indices. It should put here a nan. Instead of 85, it should put here a nan. That's what I understand the philosophy. But if you are saying not, okay, we'll check it. I believe this should be done, because the pandas should be clever enough to understand this. Okay, in other situation we'll understand. We'll see. Let's see. We'll proceed and let's see. Okay. Okay. So this is your data frame, right? So now you can create data frame from list of dictionaries. Earlier we used dictionaries of lists. Now we will create a list of dictionary, and that will use as a data, and this the collection of data. So we have a data now, and you can understand from the square bracket beginning and the square bracket end that it is basically a list. Whatever is inside doesn't matter. It is a list. So inside that you can recognize there is the dictionary. First element is the dictionary. So it is X is key of this first dictionary, and its corresponding value is 2. Key is Y, corresponding value 10. Similarly, you have key is X, value 4, key is Y, value 20, and all the keys are same here. It's a trivial one, X, Y, X, Y, X, Y, and the corresponding values. So you have a list of 4 dictionaries, and inside each dictionary you have 2 entries, and inside one entry you have single one key corresponding to one key. You have a scalar. You have a value 2, value 10, no lists. You can even more complicate even more, and can check how the data frames are being formed. Okay. Anyway, so if I have data now, and you now put inside this pd.dataframe, you can guess what it can be, because I have given the hint already. Because I have given the hint that index is given by my A, B, C, D. That is, index is nothing. It is not coming from this data. So obviously the XY, the keys will again go to the columns, of course. You can understand that. So pd.dataframe, inside that I put data, and the data is the form of list of dictionaries, and the index is the list of 4 names, 4 strings. Now you see the data frame is now made of, it looks like this, because see, it will collect all the X. So X column, X for the X column, it will collect 2 from here, 4 from here, 6 from the third dictionary, and 8 from the fourth dictionary. So 2, 4, 6, 8. And correspondingly, Y is another column, and it will collect 10 from here, 20, 30 from here, and 40 from here. So this is your data frame from a list of dictionaries. That means you now know you can create your data frame, means your two-dimensional frame, one step above the series, and you can create that from a single one-dimensional array. You can create that from two-dimensional array. You can create that from a pure dictionary of scalars, of scalar values. You can create that from a dictionary of where the values are as if in the form of a list. And now you see you can create a data frame where the data is in the form of list of dictionaries. So you can go one step above, and all the hierarchical structures. And finally, you get back some data frame. And now you see in the same way we did earlier. So this referencing dx, of course, it will give you the so x means I wanted to mean that is the entire column. So 2, 4, 6, 8. So if I give this, so it will give you along with the indices, row indices A, B, C, D. So also on my interpreter, it gave the name of the column, and also it gave the data type integer 64. And it depends. It may not it may not be integer 64 for you. It could be integer 32 for you. It depends on the interpreter or the machine you are using. Okay. So this is dx. If I write exactly the same way, dx of b, of course, I will get this value. So it will be the x column and the b row. So obviously I'll get back 4. So this is this. And now you have a data frame from dictionary of series. So you are going one step above. You had the dictionary of lists, then the list of dictionaries, then the dictionary of series. Okay, let's see. You have index A, B, C, D, and you have created one series, pd.series, and you rename it as say S1, series 1, and you give 5, 8, 9, 11, and also you could you put index here so that it will be a series. That means you will have one column 5, 8, 9, 11 like this, and the indices will be A, B, C, D. The row indices will be A, B, C, D. That's it. You have similarly another series 7, 6, 4, 3, and the index will be same A, B, C, D. Right? So you have now created a dictionary. So it is a dictionary of series. So the A is the key, capital A, colon S1. B is the another key, and the corresponding value is your series S2. So obviously you can understand what is going to happen. If you now write D equal to PD dot data frame, inside that you put this data. So data is now a dictionary, but it is a dictionary of series. And now you have this, and that it should be logically it should be right. So A corresponds to the A column, B key corresponding to B column. So always one thing is never confusing. One thing is that in the dictionary, the keys always go over to in the data frame, of course. Keys always go over to the column naming. But in the series, of course, it is different, because series you have only single column, so it doesn't know what to do. So it sends it to the as the row indices. So that's the only difference we remember. We should not confuse with series and these things. But you can recognize that in this data frame, so this is one series and this is one series, as if it is a stacking of two series. So it's kind of that. So it is, coming through a different kind of machinery. But it is as if you are writing two columns side by side. That means two series side by side, and you get a data frame. Of course, one data frame is nothing but a structure where the columns are more than one. That's it. That is the pure data frame. Yeah. you could have a trivial data frame where it looks like a series where the column is only one. Okay, add column to data frame. If you have a, like you have got a table, you understand that your data frame is nothing but basically a table. The table you incorporate, you import, we see here as a data frame. That's it. So like you have got a table and you want to create another column now after, and we handle it. Some data is coming later on, or you want to add one extra column, so that you can do. Yes. See, your D is your capital D is your data frame here. Capital D name is your data frame, and you had these A and B two columns. Now I add one extra column C, and I could write it as PD dot data frame, and inside that I write this as data. It's a new thing I create. C colon, that means I give it as a dictionary. C colon, that means understand C colon, C quote unquote C, that means C is the key, and the colon, and the data is in the form of dictionary. I mean, the value of the dictionary is in the form of a series, and of course the index. I put index inside the series itself. Okay, so you have this. You can do it in very many ways, so that basically the C is actually added with this. So you had this AB thing, data frame. Now you are adding the C column with it. So that is your so new. I mean, you just added one more column, and you can actually. I think you can actually with data given, extra data given, you can add rows also. You can explore. Okay, I just show some part which will be useful for my next application talk. Okay, now it is easier. Why I will make another dictionary and data frame? I can simply give, because I know each column is basically a series. So I write D with this C quote unquote, I mean the C column. I create new C column equal to simply a series, because I know each column is a series. So I write pd.series 10, 20, 30, 40, and the index, the same index I give. So the same result. So either you do this way, but this is foolish. I think I should do this way. Why I will create another cumbersome way. This is the series. Simply I create a series and give. So I have now the new data frame. Okay. So this is something that we have now shown that you can create your data frame in any the data with the data and index and column, but the data can be given in any form, in the dictionary of series, dictionary of list of dictionaries, simply two-dimensional array, two-dimensional list, etc., etc. It depends on how you construct your data frame. But most often you do not have to construct a data frame. You get data, and when you deal with big data analysis, big data analysis, so you get data and then you convert them through the Pandas machinery into a data frame. And then if you know certain methods of how to deal with this data, and then your life will be easy. Okay. Delete columns and rows. You have the data frame like this, and simply del is the command, del D, and you write D of A. A means the A column, simply this. And this is like a DOS command. You write del A, del D, A. A is the A column. So you can delete one column itself. You can check the location. This is very important, because if you have a huge data set, you want to see whether some number somewhere appears, or the location of particular thing somewhere. This will be very useful. So LOC is location, and you give the name of the entity, name of the B here, and the B is the reference of the row, and you see it shows you to different way, because now ABC are the columns. It were the columns, but when showing, it is showing you like this. Never mind, you go again. See, if you want to have B, right? B means it will show you right what it's showing. Yeah, it's I think it's 620. Let's see ABC. Oh, here. If your B is here without before deleting, I was dealing later with the original D. Okay. See the when you apply del, the column is permanently deleted. So you have to either copy this to some name or so. Otherwise, you can be in trouble. So you check beforehand. So imagine this data frame. So B reference is the small b reference is this row 8, 6, 20. Remember this. And the 8 corresponds to A column, 6 corresponds to B column, and your 20 corresponds to C column, right? So now you see location of B. That means we are thinking of the B row whose name is B. So it is giving you A, B, C, 3 columns. It could be written upside down. I mean the rotating like that, but it is not showing this way. I think it may also depend on the interpreter. You can check. So it is anyway giving this form. I mean fetching the 8 number from the A column, 6 from the B column, and 20 from the C column. I location. This is the index of location. When you want to search with the index number, you do not know the name of the thing row it is appearing. You do not know the name of the row. You want to check what is there in the first row, 0th row, first row. So I lock 1. Of course, it will give you the same thing. And of course, it is so sober that it is giving you the name of the row it is giving you, and the data type, depending on your machine and thing. Okay, so this is the very useful thing with which you can actually locate data, particular, I mean, data means you can also write here square bracket, something capital B or something, it would give you probably 6. You can check on your interpreter. You could write here again another square bracket, say capital B, quote unquote, it would give you 6 or so. It would, I think it will give. You can check. Okay, so that is very important. You can find out one row what is there. You can find out what is one element particularly is there. What is under one column which is there. This will be very useful when you are really dealing with actual big data set. The data, entire data you cannot see at a glance. Well, if you this slicing again, like series, like NumPy arrays, everything you can actually slice. You see, you sliced 1:3. That means 0th row is dropped. This is the first row, and this is the second row, and it won't touch 3. And the columns are intact, ABC. So this is the slicing. So I'll tell you, the young people again and again, the slicing business is very, very useful and very, very important. You always keep in mind for 1-dimensional, 2-dimensional, 3-dimensional, your arrays, NumPy arrays and things like that, you have to keep in you have to visualize automatically. I mean, you will get to it. You will get used to it. You will understand what this slicing will do, how much portion of data, a chunk of data I can take out and use for my purpose, etc., etc. These things will be very useful for data manipulation later when you really will deal with big data. Well, if I write of this, you see this creates 1:3 creates this thing, and on it I write A, another referencing A. That means it will come under A, right? It will come under right A. So 8, 9, and see B, C. And it will also give you the, whenever I am referencing through this, it will give me the name and the data type. So this is about location and slicing. And now the, again, repetitive thing. All the methods you are going to see, or you are seeing them here, you have actually seen them in ADG's class again and again, and we'll use them in all these things. Okay. So now I have a data frame where the data is, you see, this is not a 1-dimensional list, it's a 2-dimensional list. -1, 0, -2. So you have a 2 square brackets here, right? and index equal to, I want to have index equal to E. It's a new index. I had ABCD probably, right? I had ABCD. I have ABCD probably. I now have an index, new index E, and the columns I have the same ABC. Let's see what it does. My D1 is here. So I have a mini data frame where I have three columns ABC. Columns are given by the keyword columns, and the index is given by the keyword index, and I have the single index E, right? E. So now I append data frame to data frame. Like I append array to array, I can append with the append function. I can append data frame to data frame. So I append d dot append. D was the earlier data frame I just showed, and with this you append this capital D1. So yes, you see the last this row E is these things fitting here. Okay, so it is a kind of, you can think, probably Abhijit told you, it is kind of broadcasting. I mean, it understands it is actually fitting here because this row is actually fitting here. A, B, C. The columns are also matching, and so it is no problem in putting here. Okay, if I would have another column, it would have problem, of course, and so on. So this is your append thing. So all these things, you know it, and you are seeing it again and again and again. And you can also use a method called drop. You can drop it. I have dropped the 8th. You see, I have dropped the 8th. This first, I mean the 8th row. The name of is A. So you can drop it. Drop means khatam. You just drop it. Okay. You will check whether I directly have done that. You will check yourself whether the actual data frame is changed or not. Probably not. So you can rename it with in another name. So you can check it on your interpreter. Since you are doing it on interpreter, I am doing on PPT. So I am handicapped now because I don't want to go out of the PPT. Then it will take more time. Okay, so this is these things you can drop. So it's deleted the indexed row. Okay, re-indexing. This is another thing you can do. Suppose you have a data frame like this, and you have the d dot index, and you have the data here. A range, np dot a range 227. You create 2, 3, 4, 5, 6, 5 data only. And you have given this as x and y index. Actually, this will go to column here. I have not said anything here. Okay, let's see what it does. It is actually doing what it is doing. It is re-indexing, means it is actually indexing like D. What was D? D was here, these things. But it doesn't know what to, I think, do 3. Oh, I mean, indices are re-indexed. Oh, right. So re-indexing means the index. So index was 1, 2, 3, 4, 5. And I now force the index is 2 to 7. That means I re-index as 2, 3, 4, 5, 6. Since it doesn't know what is under 6, it is putting that. So these things you will experience from...
I can see that the first 2 rows are dropped, and now it has started from the 3rd row, and therefore
not first row. First row, 0th row is dropped.
First 2 rows are dropped. See?
No. 0th row. I mean, 1th row. 1th row.
1th row is dropped.
1th row is dropped. Yes, because I have indexed. I have not referred it. I have re-indexed from 2 to 6, not 1 to 6. You see, the index was from 1, 2, 3, 4, 5 originally, right? But now I am re-indexing with 2 to 7. That means I am telling that my indexing will be 2, 3, 4, 5, 6. But since 1 is not there, it is dropped. But since 6 under index number 6, nothing is there, so it is putting NaN. That is the thing. And now here, this is the columns. These are the columns, X and Y. It is clear, Runavada? You see, just you can Yeah, you can type it. Yeah, okay.
It's a kind of slicing plus an extra.
Yes. Extra. This means 6 number column, but column index 6. It doesn't. The values are not here. I'm not putting the values. I'm only re-indexing them. That means I'm changing the indices. So it does. So that's the important example here. Whenever it doesn't see any data, but I am forcing it to index, so it will put nan. So that is a good boy. So it will put nan. And if you keep it free, I mean empty space, then often when I deal with data, it will give you trouble, because in the global searching or something, nan word you can write. You can write nan wherever nan appears, but the space is something will be a little more. I mean, not so easy to find out. Or also you can count the nans easily. So how many places are empty and with nan? Nan means you can understand there is nothing. I mean, I could not provide data. That's why it is nan. Okay. So so reindexing done. So now pandas part 3, but I will tell these pandas. The part 3 is about. I'll show some example of data frame, which I will actually show on Anaconda, but I will quickly go through it because I made the PPT and it is here, so I will quickly go through it. I will actually show it on Anaconda Jupyter Notebook. So quote unquote big data. So that is with data frame. What we do? It is a procedure. So now we know series and data frame. We do not yet know the panel, other kind of form, another hierarchical structure. But mostly I can tell you whatever from my own little experience, I see the most, in all cases, data frame is the most useful thing. It is always in use. Other forms are hardly comes in of use. Okay, so data frame. So suppose you have a data source, some HTTP, some etc., some coronavirus data, which I will show you later. So this is your site. You go there, and you see the name of the there is all the site address, and you will find the data. You will find the data file. The data file will be a CSV file there. But the thing I used, you can have various kinds of data files. You can have a HTML file. You can even find it. Tables. Just you go to Worldometer, you see the display of tables. They won't give you data, but you can create data from the display table. That is called web scraping. If we have time later, or Anando can tell tomorrow or something, we can go a little bit about that. That's very fancy for young people. It's very fancy. You go to any website, you don't see data. People always don't give you raw data. They can give you sometimes some display table, but the tables are decorated. But from behind the table there is a HTML source code. You can dig there, and you can fetch this table, and you can form a data frame, and etc. But anyway, today my task will be easy. I won't go to web scraping kind of thing today because it will take more time. So the data file I'll talk about is CSV. CSV is comma separated value. That doesn't mean that the file has to be, the data will always be written as comma, comma, comma. It can have a gap, space. It can have a semicolon, etc. Delimiter can be anything. So the all these files are called CSV file. Earlier it was called TSV, tab separated file. Then there are TSV, CSV, all kinds of things are there. And you can actually go to Excel sheet. And if you have an Excel sheet, if you try to save it, you can save it as XLSX in this form. And you can also save it as CSV style. You can check that, save as CSV type. And it looks like your Excel sheet only, but the style is your CSV. So I will talk about the CSV file only today. So comma separated value, yes. So it is your real Excel sheet I will talk about. And I have downloaded this thing from this site. And you need not read this because I will show it actually. You need not read this. just appearance of this sheet. And I have saved this data. I mean, they actually saved the data in the form of CSV file. If not, I could save this in as CSV file in my computer. Well, now you import pandas as PD. And of course, when you see dir, earlier I missed, and now you see lots of things it will show. And inside that you will see two things: read underscore CSV, that is a function. Of course, you understand this reads CSV file. Then of course you have another thing, read underscore Excel. It actually reads Excel file. And then there are other, also we will use pivot table for our contour plotting today. And then there are other, there are pickle, convert to pickle format, convert to P series, etc. So lots of different options are there. So read pickle. So the pickle format tables are read underscore pickle. Then paraquet, I don't know what is paraquet, etc. etc. Then the JSON JavaScript file on these things. So Java file. Then the read HTML. So it reads HTML file, etc. etc. Even your the only one thing I will concentrate, read CSV. And this read CSV function is so powerful that it can even read your zip file. If you have a data file, CSV file, but it is so big, like you are working in suppose in some collaboration, CERN collaboration or somewhere, you have a huge data set, and the data came under zipped way, and it can also read zip files. So this is very interesting. It's very powerful. So once you have, I iterate again. Say once you have NumPy arrays at your hand, a NumPy package at your hand, and you have on top of it pandas, then you know what you can do. You are the king of data. Even you can do anything with your data. Okay, and then matplotlib will come. You plot. Then later Seaborn, etc. All these fancy packages will come with which you can produce beautiful plots. And the algorithm is at your hand. You do modeling, like Ornahuda will talk about a little bit, and you can do wonder. Well, so this is a directory, and you can see what with the help pd.readcsv what it shows. And if you write pd.readcsv, and if suppose you have saved the file in your some directory, if you give the whole path name and the name of the file, it is written as .csv. Of course, the extension is important. That is, with that it will recognize. So it will read that, and you understand df is data frame. So that I rename this as df. You can give any name. Just to tell you that this data, I mean, if you type that, you will see it will write you pandas.co.frame.dataframe. That means done. Your data, your Excel sheet is now converted to data frame. And you can see head like this, etc. etc. I'll show you on live. And you have these certain machineries. Df is your data frame. You apply this method to underscore numpy. It is already done by someone for you. So it will automatically create to numpy. You can also write to list, to list, no underscore. That is there in the directory. You will see it will create a direct list. So it will create a numpy array for you. It will create a list for you, etc. etc. So if you write L and you have a numpy array, and you see in this display, there are some places I will show you the data are put as nan. That means the data on this column was not there. So that is what I was talking about. And you now know, once you have a numpy array, you know how to handle them. So you can type this now L is your numpy array, and so on. L your shape you can do, etc. etc. And if you have a plain text, for example, suppose you write this plain text, you write your own data with the notepad on your Windows or on your Linux through some Vim or some gedit or something. You write a plain text file. Okay, so you write some headline, some city, petrol, diesel, tea. and then the names here, these are the indices, and then you have the data